Hello everyone. Today we are going to see one more example of a part program for CNC lathe. But before this, I want to tell you something, that is the information which needs by a CNC machine. Okay, that means whatever the input is required to a for CNC machine. So let us see one by one. So first, the information which is needed to the CNC machine is a preparatory information. In preparatory informations, it includes units, also increments steel or absolute positioning system. Okay, and the latter it needs the coordinates: x coordinate, y coordinate, z coordinate, rx, ry, rz. Then later the machining parameters needed by CNC, that is feed rate and spindle speed. And then the coolant control, the coolant on, coolant off, whether the coolant is in flood or is in mist. Okay, and after that it needs the tool control operation, that is tool and tool parameters. Then the cycle functions, type of action required. Okay, and last, that is the miscellaneous control, that is spindle on off, direction of rotation stop, or part movement rotation. The information is conveyed to the CNC machine through a set of instructions arranged in a desired sequence called as a program. Okay, so now let us see the today's program. Okay, so as I already said you, here the program is regarding the turning. Okay, so here if you observe, the horizontal axis is a z axis. As I already said you, the spindle axis is always z axis. Okay, and here the vertical axis is a x axis. In this, the y axis is neglected. Okay, so here you can see this is the figure. Here I have already written the program, and here we are going to see the meaning of the each block. Okay, so let us see one by one block. So first, p1 is nothing but a program identification number. Okay, and after that we have started the sequence from n05. Okay, n05, m06, t01. As we know, the m06 is for a tool change. Okay, so here we are going to change the previous tool with our current tool. That's why we have used the m06, t01. Then the next block is that n10, g97, s800, m03. Okay, now here g97 is for a fixed speed, that is a constant spindle speed, having 800 rpm, and m03 is a clockwise direction. The spindle's direction is a clockwise direction. Okay, now the next block is n15, g42, g00, x0, z0. So in this, g42 is there. G42 is for the tool's nose radius or tool radius compensation. Right mode on is there. Now let us see the function and the purpose of this tool radius compensation. Normally the let us see initially, normally the tool nose is generally a rounded shape. Okay, but in hypothetically, tool nose is treated as a point. Okay, as the tool nose for programming, with such a programming, an error causes by the tool rounding. Okay, so what happens, actual shape is a tool's nose is a round shape, but hypothetically we treat as a point. So what happens, the error is occurs, okay, during taper turning or arc interpolation between the actual program shape and the cutting shape. Okay, hence the nose radius or tool radius compensation is a function for automatically calculating and offsetting this error by setting the nose radius or a tool radius value. Okay, so here there are two G codes are there for it. So G42 is for nose radius or tool radius compensation right mode on, and G41 is for a nose radius or tool radius compensation left mode on. Okay, and now let us see the next. Here the tools position is given in the N15 block. So if you see the coordinates x0 and z0 is here. Okay, that means the initial position is over here. Okay, so also I am going to repeat one thing. As in programming there are three major parts: part 1 program setup, part 2 chip removal, part 3 system shutdown. So here the program we set. Okay, program setup we did. Now let us move the second part. So here we will see the next block: N20, G01, X25, G95, F0.3. So here I have taken X25. I can also take X25 Z0 also. Okay, so here you can see N20, G01, X25, G95, F0.3. G95 is nothing but mm per revolution. That means the field is 0.3 mm per revolution. Okay, now next code, that is N25, G01, X25, Z minus 7.5. So initially we moved the tool from 1 to 2. Okay, so here we have defined the position in a N15 block. Then in N20 block we moved the tool from here to here. Okay, now in N25 block we moved the position having the coordinate x25 and z minus 7.5 from here to here. Okay, now we are going to move the tool further, that we will see N30, Z01, X40, Z minus 15. That means we did the taper turning over here. Okay, after that we are going to move the tool from here to here, that is horizontal towards left. So the coordinate will be, you can see in next block, that is N35 block, Z01, X40, Z minus 25. So currently our tool is over here. Now we are going to do the taper turning. Okay, so it is defined in next block, that is N40, G01, X60, Z minus 35. Okay, our tool is arrived over here and we have finished the cut. But here I want to tell you one more thing, that here you can see in after N20 block, that is I have written over there N20, G01, X25, G95, F0, F0.3. Now in next block it depends on you. I have written here N25, G01, X25, Z minus 7.5. Instead of these two coordinates you can write only one also. That means N25, G01, Z minus 7.5. Okay, because x remains same and here you are going to just give the z coordinate. Okay, so depends on you, either give on at this stage one coordinate or two coordinates. Okay, same thing you can do in N35 block also. Okay, in that block you can write as a N35 G01 Z minus 25. Okay, so in such a way you can do the programming. Okay, but here let us finish first of all, then we will discuss. Then the next programming is, next block is N45 Z40 G00 X10 Z10. That means we are going to move the tool to a safe position, but G40 is for whatever the we said, we have made a change, that is we set the tool radius compensation on. Now by inserting this G40 code, we are going to cancel the tool radius compensation mode. Okay, and X10 Z10, that means we move the tool to a safe position. Okay, so here you can do one more thing, and the M02 is a, that is program end. Okay, so here you can do one more thing, as I said in previous lecture also. You can mark the points over here, say for example point 1 over here, point 2, point 3, point 4, point 5, point 6. Okay, here you can write the points 1 2 3 4 5 6. Okay, and along with that you can write the x coordinate, x value and z value. Okay, so whenever you do the program, it will become you to easy to do the programming. Okay, so you can add that one also, that is initial position, first point over here, second point, third point, fourth point, fifth point and sixth point over here. In such a way you can do the programming also. Okay, so here you can see we did the programming for this CNC lathe. Okay, now I am going to repeat the codes which we have used in this programming. So P1 is program identification number, N is a sequence number, M06 is for a tool change. Okay, then G97, it is for a constant spindle speed. Okay, M03 for a spindle's rotation in clockwise direction. G42 is a tool radius compensation, right mode on. Then G00 for a rapid transfers. Then G01 is for a linear interpolation. Then G40 is for tool radius compensation mode cancel. Okay, then M02 is for a program end. Okay, so these codes we have used, and here I am going to repeat the three major parts which I told you. So first program setup, second chip removal, third one is the system shutdown. So in this program setup we did the program setup in first three blocks. Okay, then up to N15, then we did the chip removal process from N20 to N40. Okay, and after that we can either say N40 or N45. Then the system shutdown, that is N40, and after N45 and N50 for a system shutdown. That means whatever the in initially, if you see the in program setup, what we did, that we changed the tool, then we uh, set the tool radius compensation mode, we have given the speed, also we have given the direction of a rotation. Okay, and also we have given the feed, that is constant spindle speed. Okay, that we did in a program setup. Okay, and whatever we have given the tool movement in x-axis and z-axis, this all the movement is for a chip removal. Okay, and whatever the remaining is here, that is G40 and M02, that is for a tool radius compensation mode off, and M02 is for a program end. Here also you can do one thing, you can add also before M02 you can add M02 also. Okay, for spindle stop. Okay, and then 55 you can write as a M02 also. Okay, so it completely depends on you how to write. And also I said to you that here we have neglected the y coordinate. Okay, and also in this program you can write at many blocks. Instead of two coordinates you can write one coordinate also. As in n25 you can write, instead of the n25 g01 x25 z minus 7.5, instead of this you can write n25 g01 z minus 7.5. okay, so in such a way you can write. And same thing you can write in n35 block. The currently we have written that n35 g01 x40 z minus 25. So instead of this you can write that n35 g01 z minus 25. okay, so if the value remains same, then there is no need to write it again, because it saves your time. okay, because previously you are writing x the coordinate, again you are writing the x coordinate, so it consumes your time also. So instead of this you can directly write the z coordinates also. okay, so again here you can see we have written at every place g01. okay, so here the continuously the linear movement is there, that we are removing the material continuously. At the end, if you see, we are moving the tool rapidly to a safe position. So while moving this tool I have taken the x10 and z10. If you want you can keep this position as a x5 z5 also, so it depends on you and your assumptions. okay, so here we have seen the programming for a CNC lathe, but and especially for a turning. okay, now till now here we have seen it. okay, so you can do the part program in such a way for CNC lathe also. And here I have already told you that I have taken the sequence number n05, n10, n15, n20, n25, n30, n35 in such a way. But if you want you can take the n01, n5, n10, or you can start in such a way that n05, n010, n015 in such a way, or you can write as n010, n020, n030, n040. In such a way you can also write the program also. okay, so here we have seen that how to do the part programming for a CNC lathe. So I am going to show you once again. So here it is our figure that we are supposed to achieve this shape. okay, as the steps are 25 mm diameter, 40 mm diameter and 60 mm diameter. okay, so to do this you are supposed to write the program in such a way. Here we have seen the various codes which we have used. Still I am repeat the last type. In any part programming there are three major parts: program setup, chip removal, system shutdown. So in this we have used the following codes. First it is P1 is the program identification number, N is sequence number, M06 is for a tool change. okay, then G97 is for a constant spindle speed, S800 is a 800 rpm. okay, M03 is for giving a rotation or a direction to a spindle, that is clockwise direction. Then we have used the G42. G42 is for a tool radius compensation, right mode on. Then G00 is for rapid transfers, G01 for a linear interpolation, G40 is for cancelling the tool radius compensation mode, G and the last M02 is for a program end. okay, in such a way we have seen the part drawing for the CNC. Okay, thank you.